All right, so this is our deep dive for the units. The whole unit is about solving for x with quadratics. And the deep dive is where I take it and I explain it at the most complicated level that I can possibly explain it to you right now. And we're going to go as deep with the content as possible. So one thing to note is that every time we graph a quadratic, well, first of all, what's the up and down axis? What letter is it? This is the y, making the side-to-side one being the x. So if I were to take a quadratic and graph one, let's say it goes like this. This is my quadratic. And I don't know the equation right now, but let's say someone told me, let's say the equation, let's just call the equation f of x. We don't know what it is. But let's say it's going to equal 5. That means the y is going to be 5. So if I go up to where y is 5, 1, 2, 3, 4, 5, y being 5 is right here. And that's true all across the board. Like this is the y is 5 line. Because even all the way over here, if I go up, this would be up at 5. So this is the y being 5 line. And if you look, if I were to solve for which x makes my graph have a y of 5, there is right here, this point on this graph, the y is 5 because it's up here where 5 is. So this is one answer down here, whatever this x is. Let's count it. It's 1, 2, 3, 4, 5. But also the blue graph hits y being 5 all the way back over here. So if I go down to where that x is, it looks like it's negative 1, 2, 3, 4, 5.5. So negative 5.5. Meaning, to answer this one for when the equation equals 5, the answer is that x equals negative 5.5 and 5. Because there are two answers, two x values, that had a y value equaling 5. So then, let's say I knew the equation. Let's say instead of just saying the equation equals, I said the equation was x squared minus 3x plus 6 equals 5. Well, then you could subtract the 5 over. Then 6 minus 5 becomes 1, and that's going to equal 0. So when you solve this for x, if it was this equation of this graph, then you would get out these two answers. But I just made up this equation. So that's basically what we're doing when we solve for x. They give us some equation, and all equations can be graphed, all of them. And so when you take it, and it's saying, all right, it's equaling, what does x have to be for it to equal this number? Then you solve, and you figure out what those two x's are. So let's say I didn't say equals 5. Let's say I said equals 1. Well, for this graph equals 1, this is 1, so there's this point right here. So at 4. So when x is 4, the graph would be at 1. And then if I go the other way, it looks like right here it's at negative 3. So then mathematically, I would just subtract that 1 over and get a 5 right here instead, and then solve this for x. And when I solved this one for x, using whatever method I want, I should end up with negative 3 and 4. Again, that's if this equation was this graph, and it's not, because I'm making it up. So basically, that's the point, is because of the way the graph looks, because it's a U shape like this, there will always be two answers, one on the right side and one on the left side. Even if the quadratic was flipped upside down like this, for example, if I pick any y value, like let's say, okay, what is x if y is negative 2? So y is down here at negative 2. Well, here's one place on the graph where y is -2. And then the other place, as I come back towards the left side, this one right here also has a point where y would be -2. So then there'd be the answer of a 1 and the answer of negative, what is that? 1, 2, 3, 4, 5, 6, 7, -8. So because of the way the graph is shaped, where it hoops like that, there will always be two answers when we solve for x with quadratics. And that's why there's always two answers when we solve for x with quadratics. Because the graph curves back. There will always be two answers. Because, like, for example, well, this one, if I start on the left, it's going up and then it goes back down. So it's going to hit a value twice. Or if it went the other way, same thing, it goes down, then back up. And still, even if I say, okay, what about y being right here? Well, there'll be this answer over here and this answer over here. So that x and that x. So just because of the way the graph is shaped, there's always two answers. However, let's take this graph for example. What if I said, what is the answer when y is 6? So if I go up to a y being 1, 2, 3, 4, 5, 6. This is where y is 6. Where does my blue graph cross this y is 6 line? It doesn't cross it. So this one would have no answers, none whatsoever. However, I've told you that quadratics always have two answers. Well, what happens is if I try to solve this, if I try to make my equation equal 6, and let's say this was the equation for that graph, which it's not, when I solved it, my x's would end up being imaginary. So that's what happens when there is no graph at that value. Like there's no graph when y is 6 up here. So because there's no graph up here, how am I going to solve and get answers? Well, that's why we have imaginary answers and imaginary numbers. So that's why we get imaginary numbers sometimes, at least graphically. So other ways this can get harder besides understanding what we're doing when we're solving for x is that when you take the test, there is going to be some things I call out, but the test won't sometimes. For example, how to write the answer, whether it's in a radical form or a decimal form. I usually always tell you what to do. A lot of the times test won't. You get a pick. If it's multiple choice, then you're expected to know both answers. Because sometimes they'll put it in radical form, sometimes they'll put it in decimal form, sometimes they'll put both to trick you, and then they'll want you to know that both of them are the answer. But if it's not multiple choice, you can pick whether or not, if they don't tell you, only if they don't tell you. If they don't tell you how to write the answer, you can pick. Right? A lot of the times they won't call out what form it's in. Like they won't say this is in blank form. For example, this one, what form is it in? It's in standard form, but they won't tell you that. Sometimes all the test is going to say is solve for x, meaning they don't even tell you how to solve it. You get to pick which method to use. So in this case, you get to pick which method to use. All right, so how are you going to pick which one to use? Well, to move on, you can kind of pick whichever one's your favorite. So like, for example, this one's already in standard form. So you could use the quadratic formula, or you could factor it and use the zero product property, or you can complete the square and solve for x from there. So if it's just, this is the question, you honestly just get to pick how to solve it because there's tons of methods. Sometimes they will tell you which method to use though. Like they'll say, solve for x by using the quadratic formula. However, there might be hidden instructions within those instructions. So let me show you. If you start in standard form like this, and you just want to solve for x immediately without doing anything else, you're going to use the quadratic formula. If they start in factored form and you have the two parentheses, the quickest way to solve for x with doing nothing else is to use the zero product property, which remembers just means to set each parentheses equaling to 0 and solve. If it starts in vertex form, this is actually the normal way. Like, so typically when you solve for x, you just use backwards order of operations. Where you would subtract the k away, you would square root, you'd minus this h, all that. This is like the normal way to solve for x. These are the two weird ways because, so this one only has one x. These two have two x's in it. And because of that, you can't just solve for x the normal way, where you use backwards to PEMDAS. You have to use these two extra rules to solve it in these forms. So to go from standard, if I start in standard and I want to go to standard, this one's not applicable because it's standard already. However, if I start in standard and I want to go to factored, how do I convert standard into factored form? I use factoring. And once I'm in factoring, then after that, I use a zero product property. So, for example, they might give you a question in standard form and say use a zero product property to solve. Well, you can't do that unless it's in factored form, which means there's a hidden instruction that would say go to factored form first, then use the zero product property to solve. They might also start you in standard and say solve for x by completing the square. Completing the square is how you go to vertex form. And then once you're in completing the square, you use backwards order of operations to solve. So that's one way it can get tricky, is they can just start you with something and skip the instructions on convert into this form and just say solve by completing the square. And you have to know that you need to convert it to vertex first by completing the square, then solve it using backwards order of operations. Or if they start you here and say solve for x by using the zero product property, it means you need to factor it first, then use a zero product property. If they start you in factored form and you need to go to standard, how do you go from factored to standard? You distribute. And then once you're in standard form, then you have to use the quadratic formula to solve it. This one doesn't count because I'm already in factored in this column because this is the start in factored column. However, if I'm in factored and I want to go to vertex, how do I do it? First, I distribute to standard form. Then I complete the square to vertex form. And then once I'm in vertex form, I use the backwards order of operations to solve. Because that's always how you solve from vertex form. So if they start you with a factored form and they say complete the square to solve, it means there's tons of hidden steps because first you have to distribute to standard. Then you have to complete the square to vertex. Then you have to solve it. Finally, if they start you in vertex and you need to go to standard form, how would you do it? You would also distribute, and then you would also, once you're in standard form, use the quadratic formula to solve it. If you're in vertex form and you need to get to factored, how do you do that? Well, first you have to distribute standard form. Then once you're in standard form, you have to factor it to factored form. And then finally, once you're in factored form, you just get to use the zero product property to solve it. And this is the one that's not applicable because it is already in vertex form. So this is the gist of everything that you will need to be able to do in this test. Is if I start you in any one of these, you can solve for x from any one of them, or you can convert into any one of them and then solve for x as well. So let's show you a couple. If they say solve for x by completing this square, what form do I need to make sure I'm in? To complete the square, first you have to start it in standard form. So get to standard form. However, if you're not in standard form yet, so if you're in factored form, you distribute to standard form, then complete the square to vertex form. Then you solve for x using backwards order of operations. If they told you to solve for x by using the zero product property, what does that mean? To get to factored form, if you're not already in factored form, first you have to be in standard form. So first you have to get to standard form if you're not there yet. Then you're going to factor it to factored form. Then you're going to use the zero product property to solve, which means make each parenthesis equal 0. So that's what you do if they say that. If they say solve for x by factoring, it means the same thing. It means get yourself to standard form if you're not there yet. Then factor it to the factored form. And then you're still going to use the zero product property to solve. So for whatever reason, this one, they use both. They'll use the zero product property, which is how we're actually solving it, or they'll say factoring, which is how you get to factored form where you would use the zero product property to solve. So it's basically saying the same thing. They might just say solve for x by using the quadratic formula. Quadratic formulas in what form? You use it for standard form, so you need to get to standard form. And then solve using the quadratic formula for all of them. For the quadratic formula, zero product property, and backwards of order of operations. So what I listed right now are the 3 ways to solve for x with quadratics. There's a rule that says the equations must equal 0. They have to equal 0 before you solve it for x. So for example, let's say I had 3x squared plus 6x minus 11 equals 9. Well, if I wanted to solve this for x, it's basically in standard form, so I might think, oh, I can use the quadratic formula. Well, you can't do that yet because it doesn't equal 0 yet. So to make this 9 equal 0, I would have to minus 9 from it. That means I also have to minus 9 from which one of these 3 do I minus the 9 from? It's minus from the just 11 because it's the just number. And 9 is the just number. But when I do that, now my new equation that I do all of my math with, 8 over 11 minus 9 is negative 20. But now that it's equaling 0, I can do my math with this. I can do the quadratic formula. Or I could factor it and do the zero product property. Or I could complete the square and use backwards order of operations to solve for x now. But the important part here is that the equations must equal 0. So quickly to define things, ways we solve for x are as follows. We can solve for x using the quadratic formula. could solve for x using the zero product property. Or I could solve for x using backwards order of operations. If it's the quadratic formula I'm using, what form am I in? I have to be in standard form to use the quadratic formula. If I'm using the zero product property, what form do I have to be in? I have to be in factored form to use the zero product property. And to use backwards order of operations, which form do I have to be in? We use backwards order of operations for vertex form. So these are the ways we solve for x with quadratics. So those are 3 things you've learned in this unit. The other 3 things you've learned or that we've talked about in this unit is ways to convert between forms. Some ways we convert between forms is we can use distributing. And if we distribute things, which form do we always end up in? Distributing is how we go to standard form. I can also use factoring to convert between forms. And what does factoring get me to? Factoring is how we go to factored form. And finally, the third way we can go between forms is something called completing the square. And what is completing the square? Which form do we go to? It's how we go to vertex form. So these are the 6 things we've learned how to do in this unit so far. How to go to any of them and how to solve for x between any of them. All right, but there's a reality that sometimes it's not in one of these 3 pretty forms. So if it's not in one of the 3 pretty forms, the first thing you're going to do is ask yourself, can I write it's in one of the 3 forms? So let's say this is my equation and it says solve for x. Can I make this look like any of my 3 forms? No, I cannot. There are other letters. My forms, the only letter actually in them is the equaling part and the x part. But you see there's this extra letter. There's this extra y, and that is an issue. And so because of that, I can't even write them in one of the 3 forms. So how do I solve for x? Well, I know it's a quadratic because of the squared. So how am I going to solve for x? Well, in general, I'm just going to use backwards order of operations. Because backwards order of operations is the normal way to do it. Usually, you should actually always ask yourself first, can I use order of operations backwards? The only reason why you can't do this is if there's 2 x's. So if there's more than 1 x in an equation, we can't solve for x like normal. So we have to use either it would be the zero product property or quadratic formula. However, if you're not using one of these 2 because of more than 1 x, like if you're not using the zero product property or quadratic formula, if there is only 1 x to solve for, you're going to always use the normal way. Is backwards order of operations. So remember, my order of operations tells me that grouping is the strongest. and exponents. Then if we multiply or divide, then if we add or subtract. So the weakest one is if we're adding or subtracting. So is anything getting added or subtracted to that x? Yes, there's a plus 4. The rest of it's all getting multiplied to the x because it's all one term. But this plus 4 is getting added on, so it's the first thing we can get rid of. And what's the inverse of adding 4? Subtracting 4. So if I minus 4 here, it eliminates. If I minus 4 here, t minus 4 cannot combine because t is a t, and well, 4 is not. Those aren't 4 t's. So I just write t minus 4 on that side. So this ends up being my answer. So all of it is one term, and it's all getting multiplied and divided together, and the x also has an exponent on it. So add and subtract was the weakest. We took care of that. Is there anything being multiplied or divided to x? Yeah, actually, we have two things. We have y being multiplied, and then 1/2 the fraction means times by 1, divide by 2. So whenever I see a fraction, I personally, once we're on this step where it's just this with the fraction, it's the easiest to get rid of the bottom of the fraction because what's the inverse of dividing by 2? Multiplying both sides by 2. So if I multiply this side by 2, the 2 on bottom with the 2 on multiplying 2 cancels. But then I also have to times this side by 2. So when I multiply this side by 2, I could do 2 parentheses t minus 4 if I wanted to, and I could leave it that way. Or I could actually multiply t to both of them. So 2 times t is just 2t, and 2 times negative 4 is negative 8. So I'm going to go with this one for now. It doesn't actually matter if I left it the other way. If it's a multiple choice test, you're expected to know that it could be this answer, or it could be where it's like 2 parentheses, and that they're both the same. So now that the 2 on the bottom canceled, the 1 from the top of the fraction is still there. So is the y, and so is the x squared. If this was any number but a 1, I would have to divide it away. But having 1 yx squared is the same thing as just having yx squared, because there's one of them. I don't need to divide the 1 away. Dividing by 1 doesn't change anything. I can just make it go away. Next, I'm still looking at this. How is this y connected to the x squared? They're side by side, which means they're getting multiplied together. So multiplying is still the next weakest thing because we took care of add, subtract. So we're still on multiply, divide. So to undo the multiplying by y, what's the inverse of multiplied by y? It's dividing by y. So I have to divide both of my sides by y. Because this isn't a y and the 8's not a y, I can't actually combine any of that together. So this y divided by y will eliminate. However, on top now I have the 2 t minus 8, and it's getting divided by the y. And that's going to equal, now that my y is canceled, my x squared. And finally, to finish this one up, I have nothing else being multiplied or divided to x, but I do have it being squared. And exponents is my next weakest thing. So how do I undo the squared? What's the inverse of squaring? Square roots. So taking the square root of this side will make the squared cancel. And on this side, my answer just ends up being the square root of that whole little fraction. And that's what x equals, as long as I remember that it's not just positive, the square root of that, it's positive and negative. So I could either write a positive and a negative one, or I could just write the plus minus. So this would be my answer when I solve for x on something like this, where it's not in one of the three forms.